We are going to look at how to create functions in C. So let's start with the main program, as we know, and we are going to always include stdio.h. Okay, so maybe the question I want to do is the following. I have a number, let's say I have an integer x equal to 20. I want to output, I want to print its square. Okay, so I want to print the square of this number, so let me call it square. So I'm going to also declare the square variable. Okay, so okay, I've declared the square variable, and now I want to find the square of this number by writing a function. Why do I want to write a function? Why can't I just write sq is equal to x into x? And why do I have to write function? No, the reason is that I want to use it. Maybe I want to use I want to find squares of multiple numbers. Maybe I want to find square of again sq into sq. So if I want to use the same operation multiple times, it's better to make it into a function and call that function multiple times, because the logic for writing for building that operation, you have to do it only once. Okay, so we'll try to build complex functions with time, but right now let's keep it simple. The function we require is to print to output the square of the number given as input to the function. Okay, so now the input I want to give is the value in x, and the output is the square of it. So how do I write the function? So now on top I am going to write this function. So obviously the function has to lie outside the body of this main, because okay, and I'm going to call this function from inside, but the function has to lie outside this body. Okay, and I'm going to so I will slowly build that function. So first thing, let me call this function the square. Okay, what should the function take? The function should obviously take this integer x, right? Okay, and it should have this, and first I'm writing it in the Python syntax, and then we will slowly replace it into the C syntax. So I'm having the square, the function is going to be named square, and it requires an input x, right? Okay, and I am going to have int sq is equal to x into x. So inside the function I have basically got the square function. Now two things, I have to return this square number, and second thing is that this function which is inside, so this function does not know what this x is. Okay, is this x an integer, is this x a float, etc.? The function does not know, right? Because this int x has been declared outside, and now that x is being passed here. Now you could have had a different variable name here. You could have called it y and y, and you want to call it here this x value, you want to pass it to this function, but you don't know but this function does not know what type y is. Is the type of y an integer? Is it float? Is it double? Is it a character? Maybe it's a string. It can be anything, right? So the programmer has to tell the program what type you expect, what type of variable do you expect here. So here in this program we expect the type to be integer, y has to be an integer, so I write y here. So in the function, when I define the function name, in the brackets you have to type you have to write the type of the input variables. So the input variable type here is integer, so I have to return int y. It's clear. So that is the first thing, and now the compiler know, okay, so now it's an integer, so I have to do it, I have to compile things so that I have to keep in mind that it's an integer, so, and I process my things accordingly. Okay, because if it was float, I should have done it differently. If it's an integer, I do it differently. So I do it, I know it's an integer, I do it according to what an integer multiplication should be. Okay, now the next thing is that I return, right? So I need to return this square value, so I return sq. Okay, now again the next thing. Okay, I have returned this square value, and now this has to be, now the main body has to call this function and take this value, right? So now how do I call this main? So in the main body I call by saying square x. So sq is equal to square x means the square x function is called, the square function is called with x as input parameter. The contents inside the square function is executed, and the value, basically the square of the value, is returned. The value is returned, and then that value gets assigned to this sq here, to this variable sq here, right? Okay, now just one more slide, one more thing to be done. The thing to be done here is the fact that inside the main, C program does not know what the return type of x is. Square is. Square is a function which is returning something. The C program does not know. Inside the main, it does not know what type it is going to return. Is it going to return a float, int, anything, right? It does not know that fact. Now, to tell that it's going to return an integer, we have to tell what type of data the square function returns. Okay. So in this case, we know the square function returns an integer, so I have to tell that it's int square. Okay, so the square function returns an int, that is why an integer, that's why it's an int square. So now I got an int here, so I have it int here, and now I can print square of %d is %d x comma sq by, now I am going to compile, so sorry, gcc fnc.cc, I compile, it's good, correct, /a dot out, it's running. Okay, square of 20 is 40, is 400, sorry, wrong, the computer is correct, square of 20 is 400. Okay, I will always have this slash in here to make better. Square of 20 is 400. This is correct. Okay. Let me have equal to here, I like that notation. So if I compile and I run, square of 20 is equal to 4. This much, it's good. What if I, okay, so you might have noticed the int here, right? The main function has an int return type. Okay, so it's, so ideally you can return an integer value here for the main function. You could have returned 1 or 0 or whatever, 23. So the main function can return an integer return, and it's so the when /a dot out is called, the main function is executed, and when that execution gets over, this main function actually returns this number 23 to this terminal, which the terminal can use it for its own purpose. Okay. For for whatever purpose it would like to deal. For example, we will see that later. Now, okay, so this much is good. Now, what if I want to write a function which does not return anything? Okay, and I want to tell the compiler that it does not return. For example, let's say I want to write the square function. It does not return the square, it outputs the square function. Okay, so let me say, or let me say I write a function which, so okay, as we said, before every function I have to write what it does. So I have to write this function computes the square of the input variable and returns it, and then you have to write input number y, output. So I have to write an integer y here, output, sorry, an integer y, an integer which is the square of y. Okay, so this has to be, ideally you have to write these things before any function. Now let's say I am going to write a function which takes in two numbers and outputs the sum of squares. So for example, so this function computes the sum of square of two numbers, okay, and prints it. This is the kind of thing I want. So input is and two integers x and y. What is output we are interested in? None. Okay. So in this case again, so I am going to name it sum of squares, and I take two numbers, int x, int y. And I want to return the sum of squares, right? So I am going to write return x into okay, let me just, so let me first write this x into x plus into y. Okay, this is a shorthand method to write. Here I used a variable. I stored y into y in a variable, and I returned that the value in that variable. But here I am not going to store variables. I just computed it on the go and I returned it. Okay, this is a shorthand method to write. But okay, so okay, I was not interested in returning. I was interested in printing the sum of squares. Sorry. So I'm interested in printing the sum of squares. So let me first take this into a variable, int sum of sq is equal to this, right? And I'm going to print it here. So print f sum of squares of %d comma and %d is %d comma x comma y comma sum of sq, right? But now it's not returning anything. So if it's not returning anything, I can have what is called as a void. The void tells that this function does not return anything. This function does not return anything. That's what void does. Now I can call that function and see what happens. Okay, so let me just call it printf. I'm going to print it in a new line here. Let's print it in a new line. So I'm going to call that function sum of squares with, let me say, x comma x. Okay, so what should be the number be? It x and x, so it has to be 400 plus 400. So 800 should be the output you are expecting. I compile, run. Okay. Sum of squares of 20 and 20 is 800, but I could have written here x plus 1, so that is 20. Sum of squares of 20 and 21, if I do, I'm getting, yeah, sum of squares of 20 and 21 is 841. I could have added x into 2 here. Yeah, so sum of squares of 20 and 40 is 2000. Okay, so so this much is clear, right? Now, so this is void because it does not return anything. You can add a dummy return here if you like to show that it does not return anything. It's a dummy return, meaning there's no return. Okay, this one's clear. Now next thing, I told you that why did we make the square function? We made the square function because we said that because when we have to what is the advantage of creating a function? Because when you have to do multiple things which has the same logic, we can call the function multiple times. We don't have to worry about the logic of implementing that function multiple times. So we check that it's correct only once, and we can keep it aside. Then we don't have to worry about its logic. That's the main idea, right? So in this case, square, even though it's a simple function, I'm using in the sum of squares, I'm doing the squaring 2 times, even though I have a square function. So ideally, I should be using the square function and not using the square logic 2 times, right? So I should be using the square function again. So I should be calling the square function there rather than doing it. So how do I call? So I can write square here of x plus square here of y. Okay, but you would soon see that there is a slight mistake here, but first let me compile. What is it saying? Okay, so the compiler is saying use of undeclared identifier square. Okay, why did this arise? This is an error you will also see in your when you write C programs. This is an error which you would see many times. Okay, so that's why I generated this error, because you would see this occur, you would find this many times. So we are going to correct it this way: use of undeclared identifier square. So this square, so the compiler, you should think how the compiler works like this. The compiler starts from here. It's going through all the code. It's trying to understand each of the code. Okay, it sees here. Okay, this is a function void. Okay, good. I go inside. I'm going to check inside this thing. Oh, there's a square thing coming up. What is a square? I don't know what the square is. Right? The compiler does not know what the square function is. The square function is defined later, but the compiler is coming from here, from top to bottom. It's going. And therefore the compiler, since it's coming from top, the compiler does not know what the square function is. It sees it and says, no, I don't know what the square function is. That's what it's saying. Use of undeclared identifier square. There are 2 methods to correct this. There are 2 ways to correct this. First way is I take this, copy this here, and I copy it below. Now, according to our logic, if the compiler is coming from top, it sees a square function, it remembers, okay, I have the square function. Okay, the square function takes an integer variable as input and it outputs an integer variable. I keep it in my mind. The compiler keeps it in its mind. It comes down here, it comes to sum of squares. Good, it's coming there, and square. I know square. It takes an input, an integer input, and it outputs an integer input. Okay, things are going. I know this thing, so I just come down. There should be no error. So let's compile it again now. GCC this thing, I compile, I run. It's good. It's working correctly, perfectly. Right? So it's exactly as how we wanted. The sum of squares calls the square function, and good, perfect. This is one way to solve it, but I also told there is another way to solve it. Okay, this is it's important that you know both the methods, because sometimes this method, it won't be possible to use this method. Maybe right now you can't see that, but you will encounter it in a later class. Why there will be a time when you can't use this method, but so you should know there is another method. So what is another method? So I'm going to copy this back. Okay, I'll just do an undo. I copy this back here, and we know this method won't work. So I compile again. I compile and compile is wrong. This is the why did when I ran, I got this output. This is the compiled code of the previous a.out. I can remove this and show you. I have removed a.out. Now there's nothing in my ls. Now I can compile again the compilation did not work. ls does not have any dot out. Okay. So what we saw here was the previous a dot out, which never got rewrote because the compiler did not work. Okay, so right now the sum of squares, the compiler does not work, did not work because it does not know what the square function is. So there is another method to tell the compiler what the square function is, and the method to tell the compiler what the square function is to write in the beginning that you see there's this new function which is going to come. You will soon see a function called defined as a square function later. So keep this in mind. This is what such a command is telling. Okay, so it's telling the following lines, tells the compiler that a function called square will be defined later. Okay, and it's also telling that that function will take as input an integer and return an integer. So the compiler is told all these things, and therefore when it comes, so the compiler has been told, okay, so compiler remembers that, yeah, so there's a function square which takes these parameters and input an integer or returns an integer, etc. And it knows that, okay, it keeps that in mind. So it will also keep in mind that, okay, I have to see it later, that such a function is defined later. Okay, now it comes here, it sees sum of squares, it sees square, okay, it says that fine, it's fine because I have been told that it's, the square function with these types, data types is going to come, so it's fine. So it goes, the compiler says things are fine. Okay, I'll wait for the square function, and it goes ahead and it sees the square function and it says, okay, good, everything is fine and perfect and I am happy with things. So the compiler should work now. See, it compiled properly, right? And I can now run a dot out, and it says square of 20 is equal to 400 and sum of square of 20 and 40 is 2000. Okay, now just so to recap, what are the things we did now? So again, just follow the track of the compiler. So compiler has, it did all these things, but where does execution of the program start? The execution of the program starts from here, from the main function. The main function starts the execution. It stores the value x, the variable x to 20, and then it sees the square function and it goes to the square function here, computes the square, returns here, stores the value here, and then that value is printed. It comes down. The next step is the sum of squares. So it comes down. Okay, sum of squares function is called with the values x and x into 2. Okay, that value is now 20 and 40, so it goes there. Sum of squares, values, okay, it says x is 20 now, y is 40. It comes to the next line. The square function is called, so again it goes to the square function with value x, which is 20 now. The value is returned, that 400 is returned, and it's kind of replaced here. You can think of that place is now replaced with 400. It goes to the next part. It's square of y was 20 into 2, 40. So its square of y is called, square of y comes here, 40 into 40 is computed, returns here, 40 into 40, 1600 is stored here. So this is 400 plus 600, and therefore you get the value 2000, right? Yeah, you get the value 2000, which is printed here, and this is the execution of this code. This much is clear, right? Okay, now one more thing. I just used, in all these cases, I used the input parameters, input data type to be integer and output type to be integer. There is no reason for this. You could have used float. So let me have another thing called float, square of float, let's say, and I could have had float. Okay, and so I return float of y into y. right? I could have had float, so then I could have had a float variable here. Float y is equal to 20.3. Okay, and I can print that. So I can call printf square of percentage point to f is equal to percentage point to f equal to y, which is the first float number, that is equal to, I want the square of this float number, so I can write the square, the function directly here, and I give y here. Okay, why can I write the function directly here? You should see it as the square function gets executed, the square of float function gets executed, and the return value will be replaced here, and then it will be printed. Okay, so look at all the different combinations. You can keep in mind all the combinations. I have tried this. You could have stored this value in a variable and I used it. You could have directly called the function here. To print, you could have used 0.2f, or you could have just had 0.2f. All these things are these are all correct ways. Now, okay, so sorry, there is okay, so square of 20 is 400 and square of 20.3 is 412.09. okay, I should add a slash n so that things are fine. I added a slash n, so square of 20.30 is equal to 412.09. okay, this much I hope is clear. So this is, I mean, I could have had an integer, float, anything, right? Okay, I could have returned an integer here, for even though I take a float and an integer. What should the integer output be? If this is converted in integer, this would be 412, and I would have gotten 412. So in that case, let me see that I replace, because the square of float returns an integer, I have to replace this percentage d with an integer value, and I can see what happens in that case. Compiled, run. Yes, see, square of 20.30 is 412. Earlier it was 412.09 when it was float, but now it's an integer. I get 412. So you have the freedom. The output type can be different from the input type. That's what I wanted to bring here. The input type is float here, the output type is integer. You could have had that. Now, okay, so I hope you could have had other. You could have had a char type also as output, character type, which is denoted by char. So that can also would have in an output type or an input type. So you have the freedom to choose which type you want. Okay, so this is how you write functions. Good. Now we move on to the next